Bismillahirrahmanirrahim. Welcome to the second part of 11th lecture of Statistics and Probability Theory. We will continue with the topic multinomial distribution. In previous part, we have studied that multinomial is the extension of the binomial distribution. Here we have more than two possible outcomes or categories of the experiment, and the number of trials are fixed. Experiment is repeated a fixed number of times. Each successive trial is independent from the other trial, and probability of success remains constant. Now, example 2. The probabilities are 0.4, 0.2, 0.3 and 0.1 respectively that a delegate to a certain convention arrived by air, bus, automobile or train. It means that they are saying that there is some delegate that they arrived through bus, its probability is 0.4, and if they arrive by air, its probability is 0.4. If they arrive by bus, its probability is 0.2. If they arrive through automobile, its probability is 0.3. And if they use the train, its probability is 0.1. What is the probability that among 9 delegates randomly selected at this convention, 3 arrived by air, 3 arrived by bus, 1 arrived by automobile, and 2 arrived by train? So as you can see here that you have more than 2 possible outcomes. You have categories. This is category number 1. This is category number 2. This is category number 3. And this is category number 4. Each category has its arrival probabilities, which we can say this one is P1, this one is P2, this one is P3, and this one is P4. So the next property is the experiment is repeated a fixed number of times. So here we can see that there are 9 delegates and 3 are arriving by air. So this one is X1, and 3 are arriving by bus. So this one is X2, and 1 is arriving by automobile. So this one is X3. 2 arrived by train. So this one is X4. According to the multinomial, X1 plus X2 plus X3 plus X4 should be equal to n. Here we are stopping at X4 because we have only 4 categories: air, bus, automobile and train. So X1 is 3 plus X2 is also 3, X3 is 1 and X4 is 2, which is equal to 9, and n is 9. So this is fulfilling here that X1, X2, X3, X4, when you add them, it should be equal to 1, n, and when you add all the probabilities or all the probabilities of the categories P1 plus P2 plus P3 plus P4, it is equal to 0.4 plus 0.2 plus 0.3 plus 0.1. So this would be equal to 1. So we can use multinomial distribution here, as we know all this through the example statement that 9 delegates are arriving. Number of delegates arrived by air, number of delegates arrived by bus, number of delegates arrived by automobile, number of delegates arrived by train, and P1, P2, P3, P4 are their respective probabilities of arriving. So, what is the PDF of multinomial distribution? It is x1, x2, x3, x4, and P1, P2, P3, this one is P4, and N would be equal to N x1, x2, x3, and x4, P1 raised to power x1, P2 raised to power x2, P3 raised to power x3, and P4 raised to power x4, which is equal to 9, and x1 is 3, x2 is also 3, x3 is 1, and x4 is 2, P1 is 0.4, so it would be 0.4 raised to power 3, and P2 is 0.2, which is raised to power 3, and P3 is 0.3, which is 1 raised to power 1, and P4 is 0.1 raised to power 2, which is equal to 9 factorial over 3 factorial into 3 factorial, 1 factorial into 2 factorial into 0.4 raised to power 3 into 0.2 raised to power 3 into 0.3 raised to power 1 into 0.1 raised to power 2 which is equal to 0.0077. Example number 3. 3-card players play a series of matches. The probability that player A will win any game is 20%. The probability that player B will win is 30%. And the probability that player C will win is 50%. If they play 6 games, what is the probability that player A will win 1 game, player B will win 2 games, and player C will win 3 games? So, first of all, we will see either it is fulfilling the properties of the multinomial distribution or not. We have more than 2 possible outcomes or categories, that is, player A will win, player B will win, and player C will win. So these are 3 categories. So the possibility of binomial cannot be, we cannot think about the possibility of applying the binomial distribution here. So second one is experiment is repeated a fixed number of times they end. So they are playing 6 games. And the second one is successive trials are independent. So all the trials are independent, all the games are independent. They are playing 6 games. Each game is independent from the other game. And the last one is probability of success remains constant. So if A wins, its probability of winning is 20%. Probability of B to win is 30%. And probability of C to win is 50%. These probabilities will remain constant in each of these 6 games. That is, if they are playing the game number 1, these probabilities will remain the same. They are playing the game number 2, these probabilities will remain the same. So you can apply the multinomial distribution here. So here we can see that we have total So here we can see here that we have total 6 games. X1 is 1, X2 is 2, and X3 is 3. Player A wins 1 time, player B wins 2 times, and player C wins 3 times. As you can see, what is the probability that A will win 1 time? 1 game, player B will win 2 games, and player C will win 3 games. So X1 is associated with A, X2 is associated with B, and X3 is associated with C. And P1 is associated with the player A to win, P2 is associated with player B to win, and P3 is associated with player C to win. So by applying the multinomial, you can see from here that multinomial is n factorial over x1 factorial x2 factorial. As here we have 3 categories, x3 factorial into p1 raised to power x1, p2 raised to power x2, p3 raised to power x3. On simplifying this, as we know, n is 6, x1 is 1, x2 is 2, and x3 is 3. On simplifying this, we got 0.135, which is the probability that A will win 1 game, B will win 2 games, and C will win 3 games. And as you can see from here that x1 plus x2 plus x3, which is equal to 1 plus 2 plus 3, which is equal to 6, which is equal to n. And as we know that sum of probabilities of all possible outcomes of the experiment should be equal to 1. So we see that P1 plus P2 plus P3 is 0.2 plus 0.3 plus 0.5, which is equal to 1. Multinomial means and variances. As you know, you have more than one random variables associated here, x1, x2, xk. So we can have the marginals as x1, x2, xk, and their marginals are binomial. That is, x1 is following the binomial distribution, x2 is following the binomial, xk is following the binomial. So expected value of xi, I could be 1, 2 till k. So its mean is n into pi, as if you are finding the expected value of x1, so it would be equal to n into p1. and the variance of x1 would be equal to n into p1 into 1 minus p1.